15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you this morning?
Well, and it's good to actually see you. We're using a new interface today, untested, by the way, so this could go belly up real quick, but it enables us to see each other, which we haven't done for months.
No, that's right. And, well, you know, it's very good that we can see each other because we now know that it is really the same person that we were
Well, it
talking
makes
to
a difference
before.
Because we can sort of feed off each
that's
other's
the thing.
gestures. I can do things that people can't see that. But yeah, that one we can do that one. Anyway, it's good. It's really good. Now we've got a lot to cover today, so we better get started. The 20th anniversary of the International Space Station with permanent occupancy has just passed, and that's been celebrated. I've heard a few stories about that. On the other side of the coin, something not to celebrate is our demise, which is probably going to happen in 2068 if you read the popular press. But will it? We will certainly look into that. Some strange discovery in Titan's atmosphere. It seems to be an era of finding things in planetary atmospheres. We had Venus not so long ago, and now Titan has got something popping up. And we'll answer some audience questions. A couple of rippers today, Fred, audio questions too. Somebody asking about using telescopes at the equator and if that creates certain difficulties. And the evolution of life on other planets, how different would it be depending on the circumstances they face? It's a really good question. We'll tackle all of that today. But first, Fred, the 20th anniversary of the ISS, I clearly remember when all the hullabaloo went on about them launching this thing and it getting up there, and 20 years later it's still going strong and the BO is worse than ever.
That's probably true, yeah. Look, it's a milestone. You know, this is, I think it's one of these things that we can genuinely celebrate. So the 2nd of November 2000 was when the first crew joined, or the first permanent crew, if I can put it that way, joined the space station. So it's been continuously inhabited ever since then. That was called Expedition 1. So the NASA number their crews, where currently the crew that's up there is Expedition 64.
Wow.
So things have moved on a lot. But I think the International Space Station is just an absolute icon, first of all, of international cooperation. It is a place where national boundaries really fall very low indeed, because of course there are 5 space agencies involved. NASA, of course, Roscosmos, the Russian space agency, JAXA, the Japanese space agency, ESA, European Space Agency, and the Canadian Space Agency, and many other organizations as well, but they're the principal players in the game. What we've learned from the International Space Station is an extraordinary amount just about the way the universe works, about the way humans work in space, the way physics works in space, because lots of zero gravity experiments or microgravity experiments have been tried out. And just a couple of statistics. So far, it has hosted 241 crew members and a few space tourists, you might remember back in the early 2000s, from 19 countries. So it's a lot of people have been on board the space station.
How many Aussies?
I don't think there are any. Oh, no, I beg your pardon. No, that's not true.
Andy Thomas?
I think Andy Thomas has been.
Yeah.
Yes, I think Andy Thomas has flown on the space station. Andy's main space ride, though, was on Mir, when the Mir space station was flying. He was there for over a year, I think. It was a long period.
Yeah, it's an impressive achievement. And like I've said before, you've got this international cooperation, which sort of sometimes flies in the face of the issues we're having on Earth, mainly economic, but it is something that from time to time sort of counters what the countries are doing with each other on the planet, which I find astounding. But I'm also glad that when they're off the planet, they're up there floating around doing what they do. They're all mates, and I think that's important.
Yeah, that's right. There's perhaps I can just spruik a very nice conversation piece, which was written by Alice Gorman, who I know fairly well, who's a space archaeologist, and Justin Walsh, who's an associate professor of art history and archaeology at Chapman University. But they've put together a nice summary of this, what the space station is about. There's a couple of lovely paragraphs. One reads, "The ISS is smelly, noisy, messy, and awash in shed skin cells and crumbs. It's like a terrible share house, except you can't leave, you have to work all the time, and no one gets a good night's sleep."
Oh,
There are some perks, however, they go on. "The cupola module offers perhaps the best view available to humans anywhere, a 180-degree panorama of the Earth passing below." Isn't that
Fantastic!
lovely?
Yeah, best view in the universe at the moment. I also heard that they fixed the air leak and they used tea.
Oh, I didn't know that. Now, I missed out on that one. Yes, okay. Good. An update. Thank you.
Yeah, I caught it the other day. The air leak was discovered, and they fixed it using either tea bags or tea leaves or something. It was a really weird solution, but I talked about that issue in a sci-fi movie where they had an air leak and they fixed it with Dr. Pepper. They found it with liquid Dr. Pepper that came out the hole. Yeah. So I wasn't far wrong. They used tea.
You know, that's right. It's stick to your beverages.
Yes,
that's the bottom line.
Beverages will save the world. Yes.
Indeed.
Now, we might need a lot of them in 2068, Fred, because apparently that's when we're going to get smashed to oblivion by an asteroid. They're calling it Doomsday.
Or not.
Or not. I'm thinking the not.
Well, it's a really interesting object. I think you and I have talked about this object before, Apophis.
Oh, yes. Great name.
Yeah, it is, yeah. So Apophis will have a close approach to Earth on, and I love the date, on Friday the 13th of April, 2029. We know that will happen, and we know that it will come within the ring of geostationary satellites. We know that it will be visible to the unaided eye. It will be so near, because this thing's 300 meters across. It's big. Wow. But what we also know is that it won't hit the Earth. So that Friday the 13th, 2029 is not going to be doomsday.
I can already see the headlines, Fred. You know there's going to be several papers that are going to spell doom and gloom in 2029. They just can't. You've got to sell the paper. You've got to.
Yeah, we know which ones they are as well. Yes. Yeah. Anyway, so that's a definite no hit. But there is another close approach in 2068, and at the moment, to the best of our knowledge, that will also be a non-hit. It will miss the Earth. But what's been recognised is that Apophis is undergoing something called Yarkovsky acceleration. Oh. And I think we might have talked about this before.
Sounds familiar.
Yarkovsky acceleration. So, and it comes about when you've got a rotating object being heated by the sun. And of course, an asteroid is exactly that. So if you think about it, so if you think about this thing moving along in its orbit, the side that's facing the sun is getting heated up. But it turns out that the hottest part of the surface is not the part directly under the sun, because this thing's turning. So the hottest part of the surface is a bit further around. It corresponds to about 2:00 in the afternoon. If you think of noon being where the sun's directly overhead, the thing's turned a couple of hours further, a bit further, not a couple of hours on the asteroid, because that's a different rotation speed. But they're kind of, I'm not making it very clear, but it means the hottest part is not facing the sun. It's actually facing slightly backwards. And what that means is that part of the asteroid is releasing rather more infrared radiation than the rest of it. So it's non-uniform thermal radiation, infrared. And that radiation basically exerts a thrust, very slight thrust on the asteroid. And what it means is that the thing is essentially speeding up. The work that's been done, this is from the University of Hawaii, actually, by scientists there. And it's Dave Tholen, who's actually one of the Institute for Astronomy scientists who works on this. He says we've known for some time that an impact with Earth is not possible during the 2029 close approach. The new observations we've obtained with the Subaru telescope, I forgot to mention that. Subaru is the Japanese 8-meter telescope on Mauna Kea in Hawaii. It's a first-class instrument.
I also have a Subaru lawnmower. So,
do you? There you go. I used to have a Subaru car.
I did too. I loved it. Actually, it was my favourite car.
You know what Subaru means?
No.
It is the Japanese word for the Pleiades.
Oh.
And that's why your Subaru car had stars on it.
Oh, okay. All right. I wondered that.
There you go. Let me just go back to Dave Tholen, who says the new observations we obtained with the Subaru telescope earlier this year were good enough to reveal the Yarkovsky acceleration of Apophis. And they show that the asteroid is drifting away from a purely gravitational orbit by about 170 meters per year, which is enough to keep the 2068 impact scenario in play.
Oh, boy.
So what he's saying is, I mean, that's an astonishingly small amount. What a tiny acceleration. It changes by 170 meters per year. Yeah. When you think of the distance that an asteroid will travel in a year. But anyway, that's the bottom line. So what it means is we are not now certain that in 2068 it won't hit the Earth. Yeah. So that will naturally, what it will do is prompt further observations, and many, in fact, it may well be that within a decade, perhaps, we will know one way or the other whether there's any possibility of it hitting the Earth in 2068, just because it'll be observed to death between now and certainly well before 2068.
Well, two things.
Sorry, go ahead.
Yeah, two things come to mind. Obviously, we are very much aware of near-Earth objects. We're looking for them all the time, and you and I have talked about potential intervention. You would think by 2068 we'd have a way of giving this thing a nudge so that it misses us. I would be confident of that.
Yeah, although it's a big object.
And that was my next point. Yeah. 300-meter object, if it did hit the Earth, what would be the likely scenario from whether or not it grazed us or hit us full on?
It's an object that size is not fatal to humankind. However, it could be fatal to a city or even a state. You're talking about probably statewide damage for something like that. It would have an effect on the atmosphere generally. It might put dust into the atmosphere and reduce the temperature a bit, or some other effects. But it's not going to be a species extinction event. It's dangerous, though. It's very dangerous.
Could be bad for Tasmania.
Yeah, it would wipe out Tasmania.
Wow.
That's right.
That's scary.
Yeah, and if you think of states of similar size, that's right.
But we would be able to probably project the impact point pretty accurately and move everybody out long before this happens, surely.
That's right. The nearer you get to the time, the more accurate you have of what the scenario will be. You are right, though. It may, by 2068, the technologies we have might be good enough to move it. And in fact, in particular, if you get to a couple of decades before and it's starting to really look serious, so that's by the middle of the century, 2050 or so, then you can bet your life that remedial action will be mounted rather than just sitting waiting for it to
they'll have to dig up Bruce Willis, I'm telling you.
That might be what it needs.
That might be the solution.
Yeah.
Bruce, we need Bruce. Because I think they'll have perfected cloning by then too, so they probably could.
Oh, they probably could, yes.
All right, we'll watch with interest, but hopefully we'll not have to worry about that in 2068. You're listening to the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Thanks for joining us. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson. And a big shout out to our patrons. Now, I wanted to tell you that as of this week, we have introduced yearly plans on our Patreon page, patreon.com/spacenuts. And that's where listeners can sign up for a whole year in advance, getting 2 months discount. 2 months discount for signing up for a year. And we've already had a couple of people who have done that. And I'd like to send a big shout out to Damien Humphreys, one of our patrons and a great supporter of the Space Nuts podcast. Damien, first of all, thanks for having the faith that we're going to survive another year. really appreciate the confidence. But also, thank you for your support. We are humbled by the fact that people want to put money into the podcast. We never asked for this. We're certainly not going to make it a condition. And if you want to listen for nothing, have at it. But if you do want to become a patron, and I believe Supercast can do it this way as well, sign on to your favourite patron website, patreon.com/spacenuts or Supercast or Acast. All those details are on our website, spacenutspodcast.com, if you're interested in becoming a patron. And you can write the check to the value that you deem worthy. So if you think we're only worth $0.01 a year, well, that's, I don't think you can go that low. But, we do sincerely appreciate it. And there's bonus material for our patrons, and they get the early edition and they get it ad-free. So thank you again, Damien, and to everybody who's signed up as a patron. There are quite a few now, and it's greatly appreciated. Now, Fred, we heard not so long ago about that interesting discovery in Venus, and of course, all the popular press said, that means there's life in the atmosphere. Probably not. But now we've found something in the atmosphere of Titan, one of the great moons.
Indeed, yes, the biggest moon of Saturn, which was thoroughly explored by the Cassini spacecraft in the decade it's more than a decade actually. It's 13 years up to 2017 when it was made to basically enter Saturn's atmosphere, not to burn up because there's no oxygen in Saturn's atmosphere, but to melt and vaporize and become part of the planet about which it told us so much. So Titan, thick atmosphere. I think it's 4 times the pressure of our atmosphere here on Earth, something like that. It's really an extraordinary place. It's Titan, a cold world, surface temperature around minus 190. The surface is actually water ice, frozen solid like rock, but it's got lakes of liquid ethane and liquid methane.
What a fun place.
Okay, so that's Titan in a nutshell. Actually, one other thing I didn't say is that it's got a liquid ocean, which is a global ocean underneath the ice. So it's got everything. Yeah. It's one of my favorite places in the solar system. I'm going to read the first sentence or two of the NASA press release on this, which says, and this comes from a few days ago. NASA scientists identified a molecule in Titan's atmosphere that has never been detected in any other atmosphere. In fact, many chemists have probably barely heard of it or know how to pronounce it. And that's where it really gets interesting.
Yeah, well, I'm not going to tackle
I don't know how to pronounce it. I'm going to have a go at it, Andrew.
Well, good luck.
I think it is cyclopropenylidene.
That's a good effort. I was reading through it as you said it, and that sounds about right.
Okay. What is a lot easier is its chemical formula, which is C3H2, 3 carbon atoms, 2 hydrogen atoms. With a name like that, you'd think it'd have, dozens of different elements in it, oxygen and nitrogen and all the rest of it. But no, C3H2, cyclopropenylidene, I think that's it. So it's a simple carbon-based compound, as they say, two two types of atoms in that combination. But the excitement comes from the fact that it may be a precursor to more complex carbon-containing compounds, which is all about life, as we so often end up talking about. How was it found? By the ALMA telescope. Once again, the Atacama Large Millimeter Submillimeter Array in northern Chile, not very far from San Pedro de Atacama. Way up there, it's at about 5,000 meters, the top end of the hill on which that telescope is mounted. And what scientists were doing was essentially looking at the spectrum of Titan's atmosphere in the millimeter wave region. And so you find lots and lots of features, the spectral features. They're either absorption or emission lines. It's the same in visible light spectroscopy, where you break things up with a prism. It's a bit more complicated for millimeter wave spectroscopy. But scientists were looking through that, looking at the whole, series of spectral signatures from ALMA, and they found this chemical fingerprint. There's a lovely quote from Connor Nixon, who's a planetary scientist at NASA's Goddard Space Flight Center. He's actually a leader of the research. And he said, "When I realized I was looking at cyclopropanolidine, my first thought was, well, this is really unexpected." Talk about understatement. It's very nice. So we have, in the world of science, we do know of the existence of C3H2 elsewhere in space, most notably in clouds of gas, gas clouds like nebulae, essentially, in deep space. And the interesting part about it is this stuff tends to like to react with other chemicals. And so in deep space, where you're looking at gas clouds, nebulae, and you find it, you can you can come to terms with that, because these places are almost a vacuum. They're very, very low density gases. And if you've got cyclopropanolidine, I'm going to practice it now. I think that might be how you pronounce it. If you've got that,
you'll just perfect it, and then someone will give you the proper.
It's wrong, yeah. Oh, you're dead right there. I'll have to go and find some chemist friends. Anyway, the thing about these rarefied gas clouds in space is that the molecules are a long way apart. So even though this stuff loves to react with other molecules, it can't find any, and that's the rationale for finding it in these distant gas clouds in our galaxy. Yeah. But a planetary atmosphere is quite different from that. It's under much higher pressure. It's rarefied on its outer edges, but it's under much higher pressure. And so there are a lot more molecules in Titan's atmosphere in close proximity to C3H2. So the question is, how does it survive? Where does it come from? In fact, the NASA press release puts it perfectly. It says dense atmospheres like Titan's are hives of chemical activity. And that's why this particular observation is of interest, because it makes you wonder where the C3H2 is coming from. Maybe it's just in the upper layers of Titan's atmosphere where there's not much else, that it's fairly rarefied. But the other big puzzle is that you don't find it anywhere else. It's not showing up in any other atmosphere of the solar system, and that includes the gas giants as well as Venus and the Earth. It is unique in that regard.
What a strange discovery. And of course, it just opens up so many questions. Why is it there? How did it happen? What's it doing?
That's
if
right.
you can answer any of those questions, it might be quite a revelation, or it could just be, something ordinary that doesn't tell us much at all.
There's nothing about Titan that's ordinary, Andrew. There's another nice quote from Rosalie Lopez, who's a Titan expert, actually, at Jet Propulsion Laboratory. I'm guessing she works with with Linda Spilker, who we met last year when Linda was the Cassini mission scientist. We had her over here in Australia last year to give some talks. So Rosalie says, we're trying to figure out if Titan is habitable.
Ooh.
So we want to know what compounds from the atmosphere get to the surface, and then whether that material can get through the ice crust to the ocean below, because we think the ocean is where the habitable conditions are.
So you'd have to live
There you go.
underwater.
Yeah, that's right. But it's just it's hard to know what this means exactly as you've hinted. But it is just another example of what an extraordinary world Titan is. One final comment, Andrew, is that we've got this Dragonfly mission coming up. NASA has approved that. It's an octocopter, which will explore the surface of Titan. I can't remember when the launch date is. I think it's the 2030s. Dragonfly might well be able to cast some light on the existence of this and other weird molecules. So that's something to look forward to. Hope I'm still around then.
Yeah, me
We'll
too.
see how it goes.
Yeah, well,
Yeah.
there might be more, or there's obviously more to learn, but we might get an explanation at some time in the, I'd say not too distant future, but it is a fair way off.
Well, it's nearer than 2068. put it
Yes,
that way.
very true, very true. You're listening to the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Okay, we checked all 4 systems and skiing was a go.
Space Nuts.
This is the Space Nuts podcast, episode 227, by the way. Andrew Dunkley here with Professor Fred Watson. Now, a shout out to our social media followers, whether you are following the Space Nuts podcast official page on Facebook, whether you're following us on YouTube or Twitter or Instagram or whatever else there is. Also to the people who follow us through or listen to us through various podcast platforms, because there are so many. And I've been told that there's going to be a massive Stitcher upgrade soon. So if you're listening to us through Stitcher, I think they're about to roll out a whole new interface. So hopefully that will make your experience even better. In terms of your podcast listening. So that's something to look forward to. I think that's going to happen very, very soon. And we're on iTunes, we're on Google Podcasts, a vast array, and we thank you for listening to our podcast. Now, Fred, we have some questions to tackle today. These two are quite interesting. The first is from an unknown listener, but I'm going to guess he's an Aussie.
G'day, Andrew and Fred and fellow listeners. Really love your show. It's great. The question I would like to ask is, if a telescope is at the equator and the Earth is spinning, how is it that you can train the telescope to a point of light trillions of miles away? How is it that it doesn't blur, or do they just take a snapshot, or do they adjust the telescope to keep tracking the object in the night sky? I've never been able to quite understand this, especially if it's pointing straight up at 12 o'clock position. I understand the error of parallax, but at this scale I don't quite get it. Like the effect would be like being on a carousel and you're taking a picture from the outside in a movie camera. Anyway, I hope you can explain this to me. There's a million more questions I could ask, but that one came to mind. And you need a pause button on this recording. I find it difficult to use. Thank you again. Cheers.
No worries. I think you did rather well. So thank you for sending the
Me
question. And
too.
by the way, there are lots of errors in parallax. I'll just add that for free. But anyway, he brings up an interesting point, and I understand where he's coming from. If you were trying to film something sitting on the edge of a carousel with your camera, it would be extraordinarily difficult because of the speed of movement, and your images would probably be blurred or messy or whatever. Is it the same for telescopes on the equator?
Yeah, and it's not just the equator, Andrew, it's the whole world, because wherever you are on the Earth, except at the two poles, the sky seems to turn because of the Earth's rotation. Andrew, I'm just going to start that again. Just hang on a sec. I've got a killer noise that's starting from our dishwasher.
Oh, okay.
Hang on a sec. Okay. I'm really sorry.
No,
about
that's
that.
okay. You got to
The fan bearing in our dishwasher for the fan, when it's finished working and it's heating, the bearing's gone, so it graunches along and you can't hear anything. I don't know whether you picked it up, but
No, I didn't really.
hear
When
it.
you mentioned it, I did hear it after that.
Yeah. So yeah, Andrew, it's not just on the equator. If you think about it, wherever you stand on the Earth, apart from at the two poles, the sky appears to turn above you as the Earth rotates, and it's something that astronomers had to live with since the earliest times. That the Earth is turning, and there's not much you can do about it other than make your telescope track on the stars by constantly moving the telescope, and that's exactly how it's dealt with. So, part of our anonymous questioner's question said, do they adjust the telescope to keep tracking the object in the night sky? The answer is yes. And it's a fairly straightforward thing to do. Actually, there are two different ways of doing it. If you think about the way actually something like a theodolite is mounted, that's to say it's got an up and down and side to side motion, almost like the way a gun would be mounted. That is a little bit difficult to follow the tracking, because you've got to move both axes simultaneously at different rates to follow the tracking of the sky. Now, these days, you can do that easily with computer control. So most modern telescopes are built like that way. And a lot of very ancient ones were. But from about the late 1600s, people used something called an equatorial mounting, which is you've got the sort of theodolite device, but you tilt one of the axes over to be parallel to the Earth's axis. And it turns out that then all you've got to do is rotate it around that axis at a rate of once every 24 hours, and you'll automatically track on the sky, no matter where in the sky the telescope is pointing. That's called an equatorial mounting. They are a little bit harder to manufacture than the theodolite type of mounting, but still they're useful. They're much easier to deal with if you're doing long exposure photography, for example. And once again, that answers one of the questions that we've been asked. How come it doesn't blur, or do they just take a snapshot? No, they don't. They take long exposures usually. In fact, we used to do exposures longer than an hour when photography was the go, but now electronic detectors make your exposures much shorter. So yes, so you have a long exposure, but the telescope is tracking on the sky just to stop exactly the effect that our questioner has asked about. Long answer to a short question.
But there was an answer and there's a solution, which is the best thing about it. But would it be easier, perhaps, if you put a telescope on the moon, which we've been asked about before?
That's right, it would, but you'd still have to do the same thing, because for all it turns 27 times slower than the Earth does. It's still the moon is still turning, and it would need compensation when you're looking at highly magnified views of very distant objects.
Yeah, well, I suppose using telescopes on spaceships like the Hubble, for example, would perhaps overcome some of these problems.
Yeah, you can. They use gyros to stabilize the telescopes, like Hubble. That's
All right. I hope that answered your question. Thanks for sending it in. I really appreciate that. Let's get on to our last question. This one fascinates me because it's a question that focuses on life beyond Earth, and so far this is the only place in the universe where we know life exists, but the suspicion is that there is, at the very least, microbial life somewhere in our solar system and probably beyond. But what about advanced life? Well, Owen from Wales has a question about that.
Hi, Nutters. It's Owen Williams from Swansea in Wales. My question is about how life might evolve on another planet and whether the planet's gravity and the type of star would be a major factor. For example, if a planet had a higher gravity than Earth, would animals be smaller with thicker bones in order to support their extra weight? Also, if the star was a red dwarf, would plant leaves be a different colour than Earth because of the different colour light in order for photosynthesis to work? Thanks. Love the show.
Thank you, Owen. That's a great question. And in my most recent sci-fi novel, The Turanian Enigma, I actually focus on that issue. One of the species in the book comes from a high-gravity, high-radiation exposed planet. And I tried to portray a creature that developed as a consequence of their environment, and they are very, very different indeed. And so I've wondered about this too, Owen. So, and I know we're not astrobiologists, but it's the most likely answer, Fred, is that absolutely, that life would have to evolve in some form to adapt to the unusual circumstances or the unique circumstances they face. And we know in traveling to other worlds what those atmospheres and conditions are like, and we would not tolerate that very well. Even in terms, you've got to take into account the time of the rotation of the planet. You've got to turn the star, the radiation, the gravity. There's so much that can influence life.
That's right. So you put it in a nutshell there. It's we can't have any precursor ideas about what life might be like on one of these worlds, but it is interesting to speculate. And I actually agree with Owen that if you've got higher gravity, yes, thicker bones, maybe smaller animals, that could well be the case. It's really interesting, though, just focusing on the last part of Owen's question, which was if the star was a red dwarf, would plant leaves be a different colour from Earth because of the different colour light for photosynthesis to work? And that is almost certainly true. And actually, some relatively serious work has been done on this. Looking at a NASA feature, which actually dates back to 2007, but it's still valid, which is headlined NASA predicts non-green plants on other planets. Owen might like to follow that up. It's very easy to find. It's on the nasa.gov website. Yeah. And what this article is about is reporting work that basically allows scientists to predict what color plants are going to be on planets in other solar systems. And it's exactly as Owen says, it depends on the color temperature of the star, basically the temperature of the surface of the star. So we on Earth have evolved in such a way that the peak radiation light of the sun actually is, the plants are tuned to accepting that light for the process of photosynthesis. I might just read a bit of that NASA piece because it explains it far better than I'm able to do. In the process of photosynthesis, plants convert energy from the sun into the chemical energy in the form of glucose or sugar. The chlorophyll, I'm not doing well today, Andrew. The chlorophyll in plants absorbs more blue and red light from sunlight and less green light. Chlorophyll is green because it reflects green light more than blue and red light. And that's why we've got green leaves on our plants. Yep. But if you then imagine a star which is emitting much closer to the red, So the chemical processes are different that generate whatever sort of photosynthesis they have, then you're likely to get different coloured plants. And with a red dwarf, there's a good chance you'll get red plants. Wow. That's the bottom line.
What about a blue giant?
Yeah, well, it'll get fried in the radiation. You might have, a distant planet of a blue giant might well have blue plants as well. Blue leaves. I mean, it's really the leaves we're talking about, which are the principal organs for photosynthesis. Yeah. But I'd recommend Owen have a look at that. There is a paper associated with it, which was published in the journal Astrobiology in March 2007.
Okay, worth looking into, but fascinating discussion, because there would not be all the circumstances of potential life-bearing planets would be very different. I imagine we've found some of these worlds already that they say could harbour life. We talked recently about a couple of dozen that were probably better suited to create life than Earth. But what kind of life? Yeah. What would it look like? Would the humanoids be hairy because the circumstances dictate they require hair on their entire bodies? There's all sorts of possibilities, and it's all circumstantial, and each case would be unique, I imagine. You'd have a completely different set of circumstances under every situation you might face. And, they portray it in science fiction with all these weird and wonderful creatures, like in Star Wars and all those others. But you know what? They're probably right. I mean, to the extreme, but they're probably right.
Yes, and that's probably right.
There it is. All right. Oh, and that's a great question. Thanks for sending it in. We really appreciate it. Great to hear your voice as well. And keep your questions coming. We always love them. We've got quite a few now after our recent appeal for questions. So in the not too distant future, 2068 perhaps, we will dedicate a whole episode to some more questions, hopefully all audio questions, which would be a nice mix of voices. And you can record your questions through our website, spacenutspodcast.com, and click on the AMA tab and have a look around while you're there. There's all sorts of fun and games to be had. The Astronomy Daily tab has lots of news about what's going on, and of course the shop tab has access to all our bits and pieces if you're interested in buying presents. Christmas coming up. Books are always good. So
yes, they are.
Now, that brings us to the end. Fred, thank you so much.
Great pleasure, Andrew. Good to talk, and looks as though we might have got through the first experiment with this new recording mechanism.
Yeah, I haven't checked yet. We don't know yet. Yes, indeed. Good to talk to you, Fred. We'll catch you next week.
Sounds great. Thanks,
Professor Fred Watson, astronomer at large. And from me, Andrew Dunkley, thanks again for listening to the Space Nuts podcast. We'll catch you again real soon.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.